Hi guys, welcome to Deep Diver. In the last video we discussed a struct, and in this video we are going to discuss one more concept related to a struct, which is called receiver. We will see what are receivers and how they can be used to connect method and structs. Receiver is a very important concept and you may find it weird and confusing at first, but bear with me, it will all make sense. Let us move to the VS Code and create the required files and folders for the coding. So this is my Golang course, and here I will create one more folder. Let me name it as 12 underscore receivers. And here as usual we will add one more file, receiver.go, and here we'll add package main and then the function main. Now we are good to go. Let us try to understand it step by step. In the last video we discussed a struct and there we discussed one example of MLA. Let us use the same example here. So there we had a MLA struct which had name, then party, and then one more variable has criminal cases, which was boolean. Now let us add a function here. I will name this function as change party, and we want to, using this function, change the party of the MLA. So it will require an MLA as a parameter. So let us keep it MLA. Now my question to you is whether we should use MLA or star MLA, which is basically pointer. As we have discussed in the last video of a struct, that whenever we want to change anything in the value of the struct, then we need to pass this as a pointer. Why? Because structs are value types. If we don't pass it using pointer, what will happen? A copy of this MLA will get created and this function will receive that copy, and any change this function will make on that copy will not affect the original MLA. So here we have to have passed this MLA as a pointer, and then this change party requires one more parameter which will be new party. Okay, it will be also of type string, and here we can do MLA dot party is equal to new party. Now let us use this struct and create a variable. Name this variable as MLA1. Then we need to provide values of name, party, and hash criminal cases. Let us say name I'll keep as Ravi. I become MLA someday. Party is, let us say, Cockroach Janta Party. We are missing comma here. Let us put the commas. And the third parameter has criminal cases. Let us say I become an MLA without any criminal case. Okay. Now let us try to print it. Println MLA1 MLA1. After that we'll call this function change party. Okay, what does it expects? Pointer to an MLA, so we'll pass MLA1 and then the new party, let us say, is house party. Now we'll print this again. Let us add a string party changed. Okay, and again print this MLA1. So now let us run this code. Go run receiver dot go. So here you can see initially MLA1 party was CJP. Now it has been changed to house party. Now let us discuss one thing. If you have worked with languages like C++ or Java before, let us say in those languages I want a similar kind of thing. How we can do that? So instead of struct, let me use a class. I will use class MLA, and inside this class we'll add three variables: a string name, then a string party, and then boolean has criminal cases. Similar to this change party function in Golang, we'll have a function there as well. Let us say it returns void, and the function name is same. It accepts a MLA and then the new party. So here we'll do MLA dot party is equal to new party. And when we want to use this class and function, we'll have MLA is equal to new MLA. We'll pass some name here, then party, and then true or false. Okay, and then we'll call this function change party. We'll pass the MLA object and the new party, house party. Okay, so this is C++ or Java code similar to whatever we have written, right? Currently this change party is outside of this MLA class here, right? It accepts MLA as a parameter and then changes its party. Now what I want is, I want to add this behavior which is change party to this MLA. What I will do in that case? In that case, I can add this function inside this class, right? And get rid of this MLA, and we can do something like this. This dot party is equal to new party. This is what you will do in languages like C++ or Java, right? So here what we did, by moving this change party function inside this MLA, we made this change party a behavior of this MLA class, right? So now if you want to call this change party method, you don't need to pass this MLA. You only need to pass the new party. So the equivalent change here on line number 18 will be, we'll be calling this change party on MLA, right? And now we are only passing this new party. Okay, so here I'm not concerned about access modifier and all those things, so forgive me for that. I just wanted to make comfortable. What we are doing in Golang is nothing new. It is similar to what you already have been doing in languages like C++ and Java. Now let us move to the Golang code again. So here we want the similar thing. We want this change party function to be a behavior of this MLA. How we can do that? So that's where receivers comes into the picture. So let us look into the syntax of the receiver. Let me copy this function, comment this, and then paste it again. So here, to have a receiver, we'll add small bracket just before the function name, and then we will move this parameter inside this newly added brackets. And now this change party will have just one parameter. Okay, this new party. So whatever you see inside this bracket is called receiver, and after this change party, whatever you pass to the right of this change party function is the method parameters. So here this function code remains same, but here it is giving error, rightfully so. Okay, now we need to call this function. How we need to call this function? So in case of C++ or Java, when we move this change party inside this MLA class, we call this function using this MLA object, right? So similar kind of thing we need to do here. So we'll have to do something like this, MLA1 dot change party. Okay, and now if I run my code again, let me clear this. Go run receiver dot go. You will see initially MLA1 party was CGP cockroach Janta party, but now it has been changed to house party. Okay, so this is what receiver is. Now let me tell you one more concept of receiver. So here in this change party function we have a pointer receiver, but we can also have a value receiver. So let us say we add a function like MLA details. Okay, and this will not require any parameter, and as a receiver we'll add MLA, but this time not pointer but the value receiver. Okay, so here we can print all the details of this MLA. We can do fmt.println. First thing is name. Name we can get it using MLA dot name. Then we'll have party. Party we can get using MLA dot party. Right. Let us print these two details only. Okay. So here we'll call MLA dot. You can see MLA details as a function you are getting in the suggestion as well. So we'll call MLA details, and you will see it will print the MLA detail. So let us run the code again. Go run receiver.go. You can see it has printed name Ravi and party is house party. One thing you might ask here, in this change party function we are expecting a pointer receiver, and in this MLA details we are expecting a value receiver, but while calling these methods we are calling in a similar way. We are not using pointer in case of change party like this. Ideally it should have been like this: MLA 1 dot change party house party. Okay, let me uncomment this, comment the previous one and try to run it again. Let us see whether it works or not. So clear, go run receiver.go. You can see it worked as well. So but initially we used this one instead of this. So what happens is Go internally converts this MLA dot change party to address of MLA dot change party. So it's a convenience that Golang provides. You don't need to use the address. You can call this change party in the similar way you are calling this MLA details. Okay, when you will write code in production you will be using this receiver concept heavily, and also when we will discuss interfaces you will see these receivers again coming into action. That's it for this video. See you in the next one.